Hey everybody, Mike Turzo with HeavyTech, and today we're just going to show you how we do Finite Element Analysis, or FEA. That is the engineering analysis on metal components on our compact track loader today. We're just going to sort of show you how we do that. So this is our compact track loader arm, and today we're going to do an analysis on this bracket here that actually pivots. The hydraulic cylinder attaches to this and pushes up and down and moves the arm up and down. So I'm going to open that part up. And first, what we want to do is we want to make sure that our material is correct. So we're using A36 steel. That is 36,000 psi to yield strength steel. And that's one of the most common types of steel that we manufacture with. So first, what we want to do is we open up our study here in SolidWorks. And we've already sort of set up this study, but it's actually pretty straightforward to do the analysis. So you have to know some constraints about what the part is and what you're doing with it. So we know that this part right here is actually welded, and that's going to be, we're going to treat that as a fixed part. And then we know that this part over this pinhole here is actually where the hydraulic cylinder will push up and down. And that's really the two loads that are applied to this particular plate. And we can dive in here and you can see that we have applied a 45,000 pound force to this hole. You can actually reverse the direction, you can see, but it really doesn't matter on this part since the part is identical when it's mirrored about that axis. So it doesn't really matter which direction we're pushing on it. So that's 45,000 pounds of force on that face. And then we actually, what we do is we create a FEA mesh, and we do that. It's pretty straightforward. We learned how to do this by hand back in engineering school. You actually do an FEA analysis by creating these little triangular mesh networks and doing the resultant stress strain for each node in that mesh analysis. And that's how we used to do these type of analysis back in the old days. So nowadays we just get to create this mesh. It just told me that it'll delete the old study. So we tell it how fine a mesh density we want, and we hit go. And what's amazing is now this actually makes that mesh on this part. As you can see, it's not super fine mesh, but okay for our analysis. If we actually wanted, we could create a little finer mesh. Let's go a little finer. And this will get us slightly better results, but it also takes more processing power. So you have to sort of balance that when you're doing these kind of analysis. Then we actually run this analysis. So let's run this. And then it's going to, won't take too long. If this was a bigger part, it would could take minutes or sometimes even hours to run a very complex weldment. But what this shows is an exaggerated displacement of this component. So this isn't actually the true displacement. If you look at the true displacement right here, it actually only displaces 0.5 millimeters out at this the end of this plate. So it actually, in real life, it does not displace this much. But this gives us a good representation to see in exaggerated detail how this is going to react under the load. And then we can see the stress. This shows us where there's localized stress, what's going on in this part. It shows you that the yield strength here, 36,000 psi, is not, we haven't met that, so we haven't yielded this part, meaning this part hasn't failed. Doesn't mean that this part is okay. It just means that this little arrow is not on, we're not meeting that yield strength anywhere. But we also want to look at the factor of safety, and this particular graph shows us where is the factor of safety on this part. So we can see that anything in blue is above 3 safety factor, and our lowest is a little over 1. So that's going to tell us that we actually want to take a look at this part and probably redesign it, because safety factor of 1 is not going to cut it. we typically want at least a factor of safety of 3 on everything. So we would want this whole part to really show blue. So that tells us on the engineering side that we really want to go back and look at this part and potentially redesign it. So anyways, that's a little bit about how we do a finite element analysis on our parts. We do it all in SolidWorks here at HeavyTech. So thanks for joining us.